Hello. All right. So I should be all set up over here. Doing a quick stream today to just do a little showcase on this R2-v0 design that I'm just finishing up and releasing. So give you a little pan around. It does have rubber feet, so it doesn't really like to slide all too much. Cool sorting frame. All right, so before I boot it up, and we'll do a quick print and just go over some MISC electronic stuff, I wanted to talk about the differences between this and the standard V0 in case you're actually interested in building one. So the big ticket right off the bat is it would be very difficult to modify an existing V0 to accept this enclosure. It has a highly modified frame. It's an extended Z, and it uses Z Wrencho's boxed-in gantry design to fit around the extended frame. It also has a different type of Z belt for the Z axis, which is my design, which I essentially tried to reduce the amount of space at the bottom of the stock V0 where there's just a gap for the lead screw or the belt to run through, because I want this to be as sealed up as I can get it for the enclosure without having to actually go double pane. In order to print the parts for this machine, you need a square build volume of 250 millimeters to print parts like the dome and the max dimensions on the struts. So that should fit on any regular full-size Voron. Should be able to print the parts for this. Some of the parts are TPU. So if we look at the side here, these dampening struts, even the front strut has a tube that's all TPU, which does give quite a lot of flex and some amount of self-leveling and dampening when it's actually printing. And you'll see that a little bit later once we turn it on. What else? So with this design, I didn't want to put side hinges because I thought they would look ugly with the nice rounded corners that I made. So it has a bottom hinge for the front door, drawbridge style. And because of ergonomically, the way I wanted to use the printer is have it go all the way to the Z Max position so that I can apply a glue stick, because I still love using glue stick. I know a lot of people are not a fan, but I just find it to be the most reliable adhesion method, and I'm all about reliability. So I actually designed this Z-axis with the homing switch in the bottom. So when you give the Z-home command, the bed goes to the bottom. You can open the door easily, apply glue to the bed without the tool head being in the way, and then start your print. Okay, let's talk about electronics a little bit. So, wondering if I can get in there better than this. I can adjust the lighting. All right, cool. So you can see what's going on in here a little bit. Focus. I'm trying. Okay, well, it doesn't really seem to want to focus, but that's the best I can do. Essentially, I designed the electronics enclosure to be naked, and need to put a screw back in that. The Z-axis has a independent drive gear, so that you can actually put the motor wherever you want to put it, depending on the availability, the length of belts that you can find. This is a 280 tooth, but I also designed a motor mount for a 250 tooth if you can't find that, where it's just moved over slightly more. This lower rail is exposed to serve as a carry handle, and the whole printer weighs about 15 pounds, so it's pretty nice to have a handle somewhere on it that you can grab while you're moving it around, so that's actually convenient. I have mine set up with a Raspberry Pi stacked underneath a Pico, and then I just have a Noctura fan up here cooling the stepper motor drivers. I have a buck converter tucked behind the power inlet, and then up here underneath this printed box is an SSR, which controls the bed. This is actually a speed controller, which is linked to the Nevermore carbon filter, and I made a custom one of those. I think that's everything we got going on back here. Ethernet port just goes to the Pi. I have mine set up in access point mode, because I like to move this printer around and bring it to work sometimes. If I want, I know I'm going to be doing some printing and I want a faster printer than what we have, so this is really convenient to just pick up and bring around with you, as long as it's in access point mode so you can actually connect to it. Ethernet's fine. Access point is nice. Focus here. Cool. Anything else? All right, let's plug it in. So, it does take about 2 minutes to boot and for the screen to turn on, but in the meantime, I can show you what these switches do. The first one is the enclosure lights, and those are tucked in 2 strips that run in this direction up in the top of the dome. The second switch is for the custom carbon filter, and I'll home the printer and I'll take that basket out so you can see what's going on in there. And the third switch is currently vacant, but I'm sure I'm going to want to add other things in the future, so I have a vacant third switch. On the side over here, this gray panel is actually a pass-through, so instead of mounting that like this one where it's a flush mount and there is no pass-through, you could add switches over here without having to modify the dome file if you wanted more expansion or another LCD on the other side. I am pretty excited. Basically, I'm excited to see other people build the printer, but I'm more excited to see what people expand upon this design with, because this is just the very base astromech as opposed to adding any servos. I did have a version of the radar dish that spun on a different dome using a NEMA 14 linked to the Z-axis motor. And it works, but it was kind of overcomplicated, and it's adding more holes to something that I'm trying to enclose. So for the moment, I just released the static version, and maybe I'll revisit the radar dome at some point. So we do preheat for PLA. Okay, Z-Cruncher. Oh, glad you made it. The reason that the front door is drawbridge style is because I didn't want to put hinges on my rounded corners, because I thought it would ruin the aesthetic of, this sleek astromech if it had big bulging out corners. I will say this is depending on how you position it on a shelf or on a table, it can be really annoying to have a door that opens in this direction. get my computer out frame. All right, doing a preheat. Oh, so I can show you this for the moment. So it homes to the bottom, and then you have full clearance on the carbon basket, so you can get your 2 fingers in there. And this is just a custom Nevermore carbon filter. It is actually using the Nevermore carbon. I have a blower fan, standard 5015 on the top and bottom. So the theory is it's, intaking air all over the chamber to try to more evenly disperse it when it spits it back out. Turn the printer so you can see this. So you'll notice the printer is on a rear incline of 6 degrees, and I had to accommodate for that incline with my spool mount. This is a TPU spool mount that levels, negatively against that 6 degrees, so it still ends up being neutral instead of continuing to slide in one direction. Oh, flipping the filter to be external. That could be super interesting. Yeah, there's a lot of dead space up in the front 2 corners that you could totally cut out and do like an astromech style, just literally from the side. Take that filter in and out. That's a great idea. There's also like room here. I was thinking about, I have a model for clippers for the filament that's using nail clippers as the actual tool, but I'm not happy with it, so I didn't release it yet. But in hopefully soon future update, I will be releasing those parts once I'm happy with them. Getting what I'm doing here. All right, we're just going to print up a speedy Voron cube. No benchies today. Just taking a minute to read chat over here. So we are currently printing at 180 millimeters a second, which is the fastest I ever realistically push this for, not losing layer adhesion. Mostly, I'm sure it could comfortably go faster. It has a high flow dragon. What would I change about it? I am continuing to. It does have two fans mounted underneath the bed here, which is why this is a thickened bed chassis. Currently, I max out my bed heater speed at 25% because that's it's only a 100 watt heater, so that's as much as it can take. So I have a 150 watt on the way. I don't have a thermistor in the chamber yet, so I've just been monitoring the temperature with the hot end when it's cold. So I want to add one of those. I want to swap the heated bed for another hotter one. Otherwise, I'm actually quite pleased with the way it all came together. The things that I would change if I built another one would just be to add more things as opposed to like adjust what's already here. The TPU legs, so they definitely do. I haven't noticed resonances on the print, but they will shake this table, for instance, which has this is a standing table, so it doesn't have as much rigidity as a standard 4-leg table. So when this really gets going, it will shake the table because it's got better grip on the ground than a printer with only the 4 small feet, because this has so much rubber contact with the surface. So it will impart more force and actually like shake things. I haven't done input shaper. I can't put the accelerometer on the Pi because it's stacked beneath the Pico, and I'm not willing, like all the wires are cut to length, so it would be like next to impossible for me to have it all plugged in and plug in a accelerometer to run input shaper. I did do the cornering, I did linear advance. My next machine I'm not going to stack a Pi so that I can just put an accelerometer on it. I know you can do it manually, but I don't want to. It's fine. Oh, Z acceleration. So it's a 5-to-1 gear reduction on a full standard size NEMA 17. So I'm running it hot. I think I have 1.5 amps going to the Z motor, and I'm running Z acceleration at, I think after the gear reduction, 1,000 millimeters a second, which is as fast as I'd ever want to run it for something that's moving more than 2 pounds of weight. So it's Z hops, 2 millimeters at I think 25 millimeters a second travel speed for the Z. Yeah, 2 millimeter Z hop. Do you use more than that? Oh, I forgot we're printing PLA. So my big thing about the multi-motor Z-axes is actually not wanting to give up my manual Z home or have to fiddle with clicky. Like now we have boop, or I don't think that's technically been released yet, but we have tap. So that mitigates some of my concern, but I really just didn't want to build a printer that relied on something that docked because I feel less mechanically confident about making something that would reliably do that. So I really like my manual 3-axis bed leveling and just a single Z screw, and that's why I was so, or a belt in this case, that's why I was so attracted to the V0 because it's small enough that you can do that without too much vibration on the bed. You can see some of it. You know, the bed vibrates, but the printer is also vibrating, so. Oh wow, you do like almost no Z-hop compared to what I'm doing. So the reason I Z-hop at all is to fight overhangs when you've got, you know, a part that's warping. Um, that's typically been my biggest problem when I get layer shifts. It's just a part that warped out of spec and tried to travel over it in collision. Yo yo, Exor, you made it. Nice to see you. Oh, why 2 millimeters? Should it be more than that? Should it be less than that? It's worked fine. Again, like it does it as fast as the printer is moving in XY to the new coordinate. So doing it any faster seems irrelevant. So I haven't actually delved into Super Slicer yet because I saw it's not a like a fully packaged program, and you have to use terminal to launch it and like compile things. I was like, you know what, I'm gonna do that some other time, and I haven't gotten to it yet. So this is the latest version of Crucial Slicer, which I'm very happy with. So we are printing PLA right now, but normally I just print ABS on this machine and run it enclosed. When I do overhangs for ABS, I have a separate profile that runs the perimeters at only 40 millimeters a second, which is quite slow. So on parts that I know I have big ABS overhangs, I just use a separate profile for that currently because I don't want to run my cooling fans more than 15%, which is what I have them regularly running at for ABS. For bed adhesion, glue stick 100% of the time. Can't go wrong with glue stick. Zoom out and see how the whole printer is vibrating a little bit. Thank you. I'm quite pleased with the weathering. I'm thinking about doing some kind of like dirty bot award if other people want to weather up their bots when they build them, because like no one ever does. There's no reason to. It for normal forums, you want it to look like a clean appliance, but a clean astromech is an unused astromech. So dirtying it up just makes it look better. Oh, PLA, thank you. So you can see it rocking back and forth a little bit, not too much on this, on the geometry of this print. Wow, you run cooling at 50 to 70% for ABS? How is your layer adhesion? So there you can see it vibrating quite a bit as it's doing the gap fill. Yeah, if I run my cooling fans at like 30% for ABS, I can run my normal profile and print overhangs. It's just the layer adhesion is like halved. I don't think this chamber has actually gotten up to 50C, which is why I'm still upgrading it and getting a higher wattage for the heated bed. The hot end says it gets up to like 55 if I just let it heat soak for an hour, but that's slightly biased temperature because it's right above the heated bed. So actual air chamber temperature maybe 45, maybe 50. I will say though, the my mini V1.8 gets up to 65 in the chamber, and I have all the same problems with overhangs. One thing that it's not immediately obvious, but your gantry is now moving uphill. Only 6 degrees. I haven't seen a noticeable problem with that yet, but just something interesting that you don't see very much. This was a 4-month build. The design is like all the gantry stuff, all of the actual printer parts of the printer. You don't some of it's my work, but most of it isn't. I slightly redesigned the Z-axis. I slightly redesigned the bed. You could use the stock version of both of those. You can just use Z-Cruncho's gantry. So my work is really just the actual enclosure. And remixing the frame a little bit so that you can actually disperse the weight properly just between those two struts, 1, 2. The extrusions that those exist on, I added. They're not in the regular V0 design. And then I just modified the rest of the frame slightly to extend. For instance, you'll notice the LGX light just barely clears the top of the top extrusion when it's all the way forward. So that's as low as you could make that top of the frame. And then the dome is I believe it's a 70 millimeter Z height dome, which is as reasonably low as I was comfortable making it to accommodate for the wire relief on the inside. The struts also come off with just one screw each. There's a main screw that's an M5 that you just pop out, and then the main struts come off. The lower strut is a little bit more complicated. You have to take 2 screws out, pop the plastic part off, and then there's 3 more screws to get the rubber part off. I was thinking about redesigning it, but I was too deep at that point, and I didn't want to reprint it for another time. So it is the way it is. Oh, the nozzle currently is a 0.4 in there. Next, I have this. Let's see if I can do a pan around here. I am working on a 300 mil 2.4 over here that has a 350Z, and then probably work on some cosplay stuff before I get back to more printer builds. This has been super fun, but it's also reinvigorated me to want to work on cosplay because I had to paint it. We're getting there. So I haven't had any issues yet with printing while angled. I have printed probably about 150 hours on this machine so far. I did actually rebuild the XY gantry completely last week because I wanted to give it more play. I was shredding one of the belts on the left side, and it was because the idler I was just using cheap belts, and they were slightly too thick for the idler stack, so it was like popping out of the gear slightly. So I took the opportunity to just take the whole AB drive system apart and add M3 shim between all of the bearings to give it a little bit more play. So you can see there's a nice gap between, let me see if I can focus on this, between the bearings over there in that arm on the XY joint. Those bearings aren't sandwiched together super tight. There's a gap with a shim in it. And then I took the opportunity to add Gates belts all the way around. And now everything lines up super good. No belt shredding, no weird complaining vibration, running at 9,000 acceleration. So I'm calling it good. Longest print time. I do a lot of printing of the full volume actually for this machine, so up in the 5-hour range. No, 5 hours at this speed. So like a lot of my parts will be like 5 wall thickness, and I generally, when I'm printing for strength, will stick to 200 micron layers. So if you're filling the full build volume, yeah, even at these speeds, you can make a 5-hour print. Oh, you were getting clogs? So I have heard complaints about clogs with dragons. I actually shaved down the front edge of the dragon, the high flow dragon in this printer, because the standard AD shroud only fits the 3008 fan, and I didn't have any of those, and I didn't want to wait for one, so I shoved a 3010 in there, and just shaved down the heatsink a little bit so it actually fit. And I've had no issues with cooling. I have a standard dragon in a stealth burner that I've been running in my V1.8 for about a year now. Never once have I clogged it running ABS, PETG, and PLA, so maybe I'm getting lucky, I don't know. I've had a lot of success with dragons. Just gotta fix my mount here real quick before my camera slides out of my tripod. That'd be great. I think this is the top layer. Yeah, and then I have G-code in here to home all because it homes to the bottom. I have a Mandela rosework bed in there, so it's got all the grip you could ever want. Where's my camera? Over here. Let's get some light. So, not like the most clean overhangs ever, but it is a mini burner, so it's just got the 310 fans. And this was done at 180 millimeters a second, so I'm not too concerned. All right, a couple real quick wrap-up notes. Thank you for the kind compliments, everybody. This is a R2-v0, which means you can get a regular V0 serial plate for it, but it's also an R2-v0, which means you can get a custom R2-v0 serial plate for it, which I will give you the appropriate number in, the order for who's actually building them, and then you can mount your R2-v0 serial up on the dome, and I will add you to the gallery over on GitHub. For the actual directions, I wrote what is very much just a supplementary guide to actually assemble this machine. You're going to have to rely on the V0 standard directions and the CAD model to not forget where all of the nuts you need are. The nuts and screws and all the appropriate lengths are all in the CAD model. So I'd recommend having that open right next to you as you're trying to build this machine, so you make sure you don't forget anything, because that is the blessing and the curse of working with 1515 extrusions. There are no roll-in T-nuts, so you get the weight savings and the size reduction, but you also got to remember to do things in the right order. So this is fun. This video is going to serve as the release party and also a reference for the design, so this is going to exist on my channel at the end of the stream. Thanks everybody for joining me.